Hi guys, welcome back again. Uh, Going to next problem in the sliding window series. So we are doing lead code 3258. Found substrings that satisfy K constant one. You are given a binary string. So let's study the problem statement and see the constants and try to approach with a well-defined equation. So you are given a binary string S and an integer K. Okay, fine. It is okay and a binary string. Okay, so K constant if either of the following conditions hold. Okay, the number of zeros in the string is at most K. Okay, okay, we would say binary string satisfies K constant if either the number of zeros in the string is at most K or the number of ones in the string is at most K. So it should be either or many zeros or many ones. Return an integer donating the number of substrings of S that satisfy the K constraints. Okay, so here we have to take the substrings which are contiguous sequence of uh, binary string. So there should be at least, I mean, not at least, at most. Okay, at most. Okay, so at most one zero or one should be there, and it should not be above one. So uh, it will hold the condition, but this substring won't because we have two which is greater than one. We need to have at most one, so it won't hold the condition, but it does one, two, three, four. Also, it will hold the condition for zero, not for one, because it have at most one zero, but it won't hold like it won't hold condition true for this zero. So it will hold the condition and it will for one and this will for one for zero and no array with length 4 holds condition true and no 5 elements will do either, so it will be 1 2 3 4 5 6 7. Then where are the remaining 5? Let's check. Every substring of S except the substrings 1010, 10101 and 0101 satisfies the K constraints. Okay, we forgot one case. We took this right. We forgot substrings with length 1. So it holds the condition true. It holds the condition true. It does. It does. And also it at most. Okay. So we can have at most two ones in a substring or at most two zeros in a substring. So let's see. We can consider all ones. So we by default we'll have all the single, let's see constants first. So the length of the string will be between 1 and 50, and k will be between 1 and the length of the string. So k will always be between 1 and length of the string. So we can always consider uh, single elements. So the answer will be above the length of the string or equals to the length of the string. I hope you guys understand, because if k is 1, then uh, if it is 0 or 1, it will hold true, because for a substring of length 1, at most it will have at most only one 0 or 1 1. So let's just ignore the case where we have to count for single strings. So let's just start with length of s. We are starting with the length of s. Then what we'll be doing is, 4 5 6 7. Zero and Oh, let's check guess what's happening wrong here. We are given k equals to 1. So why do we get 14? We should have at most 1. 3, 4, 5. I think this is issue. Let's check here. All such things of a set size. Okay, guys, I think I understood. Uh, in this case, they are taking 0, which is less than. So if it is this, then they are considering 0. But we are also considering it. But probably we are missing like let's check. How is it only one less than this? So it will be 1, 2, 3, 4, 5. So this will be one substring, and for Okay, it will be n into n plus 1 by 2. So 5 into 5 plus 1 by 2, it will be, sorry, 5 into 5 minus 1 by 2, which will be, sorry, 5 plus 1 by 2 only. 5 into 5 plus 1 by 2. 5 into 5 plus 1 by 2 will be 15. Let's dry run this case. So initially we're considering 5 as an answer, and from range 2 we should consider taking a case plus 1 here. Let's see if we are getting issue. Not getting the issue. What's happening here is right. So it will be taking the entire length of the list, which will be 5. Then up to 5 it will run the for loop, but 5 is not less than 5. 5 is equal to 5, so uh, this while loop will not be triggered until here. It will go fine. So let's trace a bitting and discuss the intuition later. So this, let's try run this. 1 2 3 4 5 6. So 6 will be considered already, and k is 1. So we can consider this, 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 and this too, I guess, because there are no zeros here. This 1 2 3 4 5 6 6, right? So 6 into 6, 6 plus 1 by 2. It will be 20. It will be 21. We cannot consider the case where checking the constant in a wrong way, I guess. If C0 is less than or equal to C1 is, if both are greater than K, then it will return false. If both are less than K, then it will true, and it will be true. First one thing, we will add a log here and check what's happening wrong. check now. Oh, what happened there? I think I know what's wrong going here. We can consider this, but not this. Let's also keep also here and check whether or not ARMS is being updated. This answer. This one here. Let's see the log again. Solution 0 0. Zero, 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 one, one. Now let's see. Fine. So we are considering 0 0. This will also be treated here. Also right. Oh, let's see. So 0 0 0 0 0 0 1 2 3. We should have 3, but we are getting 4 here. And in case of 3, we get 1 2, but we're getting 3 here. So what's going wrong here is here the L value should be increasing. So one thing, 1. Let's see now. Oh, sure. 0 Now we are missing a case. 0 0 0 0 0 1. We are missing a case now. So, plus is less than. Might now raise an error. As I thought. Let's see why it's happening. Zero 1. What happened to 1 0? Social minus 1. Slicing fine, but there is issue. Let's take index instead of last slice. Now it might trigger a problem. So it should be +1 here. Okay. Now will be 3. Where equal -1 and 1 plus I. So 2 and 3. Something 1, 2, 2, 3. So guess what we are doing wrong here is now this time. Now we are checking the previous value, which will leave the edge case where for the first, like the first slide, it will add a unnecessary addition for the first slide. So instead of checking L minus 1, we are checking the Lth one, and we are continuing from L equal to 0. And so actually we are ignoring the first element, and we are taking the L plus ith element from L plus 1 nth element. So let's try submitting it and check if it is working fine or not. It is working fine, and space complexity is okay, but the time complexity is very bad. There is a huge graph up here, Let me tell you the time complexity here it's taking is around order of n square. We can make it look simple instead of this messy. So initially let's review the other codes quickly. So length of function, we should have done this. It's like it looks simple and good. So same, he's counting zero count and one count, and he's adding the values. He can reduce uh, n iterations. I mean n number of iterations. If he did the same, if he didn't initiate answer with zero, let's move forward and check the next one. Not equal to zero. Okay, the same as well. Let's check the first one. So he's using the dictionary. Left count. This one left and count. Left plus equal to one. Oh, what he doing is let's understand the diagram for right in range of n. Okay, this is f of right plus equal to one. And frequency of zero is greater than k. Nice. Interesting. He's initially adding uh, all the numbers. If it never hits this condition, if there are no like if it never hits this condition, then it will directly use this answer. That's one great way to do this thing. So he's adding until he's getting uh, the constant greater than k, and if the constant is greater than k, then he's reducing the left. It's an interesting way, and I would say it's very optimal approach. So what he's doing is he's actually doing like this. So initially it is taking this one value and adding this value. Here the k is 2, so the frequency will be 0, and the frequency of 0 is 1, frequency of 1 is 1. Okay, so 1, so since 1 is less than 2, it's fine to add another element. So now the k is 2, frequency of 1 is 2, so it's fine to take this subarray, and frequency of 0 is 2 and the frequency of 1 is also 2, which is not greater than k. Okay, so it is fine to have 4, this subarray of 4, but when we hit 10101, then frequency of 1 is 3, but frequency of 0 is still 2, so we can consider adding one more element. Now it's a invalid case, so for this what he is doing is he is getting inside the array. I mean, then he is triggering this while loop and removing one element from the left, which will give you this, and the for loop continues again. We'll add one more one, which will again trigger this uh, while loop, and he can consider this whole uh, highlighted subarray. For adding the count, he is taking right minus left plus 1, which is if he is considering this whole subarray as valid, then every subarray that will generate from this subarray is also valid. So how many subarrays will it give? That is right minus left plus 1, that which means in this case 1 0 1 2 3 4 5 6. So the left is 2 and the right is 6. So 6 minus 2, what is 6 minus 2? 4, and plus 1. It will have 5 sub, like this whole subarray is capable of making 5 subarrays. Let's count how it is possible. So this whole subarray is one subarray, and it will make a, so it is one, now it is 1. If you take a subarray of 1 2 3 4 5, this subarray contains 5 uh, elements. So now if we consider subarray of size 4 from this selected subarray, which will be 1 and 2, and if we consider, so total 2 plus 1 is 3, and subarray of length 3 is 1 2 and 3. So 3 plus 2 4, 4 plus 1, sorry, 3 plus 3 6, and of length 2 will be 1 2 3 4. So 6 plus 4 10, and single arrays will be 1 2 3 4 5. I guess you guys understand. So let's make this, let's try this approach. Let's try developing this approach. But instead of making it a dictionary, let's do a different approach. So it's an elegant way of doing things. Uh, Worst case scenario, it is also considered order of n square, but it will reduce so many cases. So for a range of length of s, keep it as right. Actually, the dictionary way he implemented is really elegant. You can do it with list also, but dictionary will be elegant. It didn't define L anywhere. We can make it even more optimal. Something wrong. No execution. Okay, we are not adding it. We are just assigning value to the answer. So let's not check it. Let's We are off by one value for adding. What's going wrong, guys? Okay, now let's check. Right. So we can optimize this even more. So instead of initializing answer from zero, we can do one thing. The count r minus count plus. Let's check if it is okay. Maybe it should be from 2. For sure, guys, I know this will work. If we are considering from 1 to length process, then the left will be 0, the right will be 1, and r minus l plus 1, right? Since it is 0 based index, it is given. Okay, let's keep it like this one. But instead, let's ask, it is complex to like just imagine how to solve it. Rather, let's ask ChatGPT. We are currently having a solution in the most optimal way in the lead code. but I know it can be even more optimized. So let's ask ChatGPT. Include single property. How we integrate array of options. Oh, okay. So that's what it's doing. Actually, guys, it's no optimal approach. It doesn't add any optimization. So the thing is, this it is just reducing this one little operation, but keeping it would be no issue, and it will make more the code look more elegant instead of doing all this bullshit. You can directly do this. You don't need any conditions to fulfill. Just updating it. See guys, this is a very simple problem, and If I end up becoming very successful in the future, then just consider one thing. If I can, like, if someone like I can become uh, successful with the level of skill I currently possess, then anyone could possess the level of skill uh, I possess in the future. So keep trying hard, work for what you believe, and keep pushing. Bye, guys.